Hi, welcome to section 4.3, which is the properties of logarithms. This definitely builds on stuff that you learned in 4.2. We are going to go through the first 3 rules, and with each one of those it has a checkpoint. So I do definitely like the way this section is organized. So we're going to start with the product rule. And if you remember in the last video, I said logarithms are just another way of writing exponents. And remember, when you multiply like bases, you add the exponents? Same thing here. So if you're doing log base b of 2 things, I'll just use the book's notation m times n, then that would equal log base b of m plus log base b of n, because you're adding the exponents. So that's the product rule, is when you're taking the log of 2 things being multiplied, it's the same as splitting up, giving them each their own log, and then adding them together. Alright, so let's look at checkpoint 1. Checkpoint 1 is to use the product rule to expand. Just put expand. Okay, for A, we have log base 6 of 7 times 11. And for B, we will have the log of 100x. Just put them both out there. So these are the 2 product rule problems we're going to use. So on A, you can definitely tell there are 2 things being multiplied. You have the 7 times 11. So we'll split that up. They each both have to be log base 6. So log base 6 of 7 plus log base 6 of 11. And then if you could evaluate those, you need to. Like, could you raise 6 to a power to get 7? Not nicely, so no. 6 to a power to 11? Not nicely, so no. This is your answer. Let's expand it out. Now part B, we're going to do the same thing. So we have a log with 2 things being multiplied. So we're going to split it. I don't think this one's quite as obvious as this one. This part A. So you have the log of 100 plus the log of x. And then if you can evaluate it, you need to. So you can actually do the log of 100, because it's 10 to what power is 100, and that's actually 2. So the last section, I would write that out, like 10 to the x equals 100. I'm not doing all that anymore, so it's just 10, because remember your base is 10. It's a common log when there's no base there. So 2 plus log of x. Alright, so that's using the product rule. And then the quotient rule goes right along with it. Quotient rule, we just have division, so that will turn into subtraction. They go together. So the log of 2 things being divided. Move this up. We have log base b of m divided by n. It's log base b of the top minus log base b of the bottom, which is n. So that's your quotient rule. So checkpoint 2 is to practice using the quotient rule. We're going to expand again. Okay, for A, we have log base 8 of 23 over x. And then for b, we have the natural log of e to the 5th over 11. Alright, so the log of two things being subtracted, or of two things being divided, it is going to become subtraction. So we have the log of the top, so log base 8 of 23, minus the log of the bottom, which is log base 8 then of x. Can we raise 8 to a power to get 23? No, we cannot. Just answer my own questions. So that's what you get. That's your answer. Alright, for b, I'm going to do the same thing. We have two things being divided, so we'll make it subtraction. So we'll have the natural log of e to the 5th minus the natural log of 11. Now, natural log of e to the 5th. That's e to what power is e to the 5th? So that's actually just 5. So you have 5 minus the natural log of 11. And 11 just looks like a bunch of more L's. Okay, so that's the quotient rule. Basically the opposite of the product rule, where multiplication becomes addition and division becomes subtraction. All right, and then the last one that goes with those two is the power rule. And the power rule is when you have something to an exponent. So let's say you have log base b of m to the p. Since a log is an exponent and a power to a power you multiply, same thing's going to happen here. You can bring that p down in front. So it'd be p times log base b of m. I'm careful not to make it look like plog. So that's your power rule. And in checkpoint 3, we'll practice using that. And then we'll put them all together. So again, the directions are to expand. Okay, we have A, we have log base 6 of 3 to the 9th. Then for B, we have the natural log of the cube root of x, which I like that problem because the power is a little hidden. And then we're going to have a C, which is the log of x plus 4 whole quantity squared. Alright, so in A, you have the 9 is your power, so the 9 will come down in front. So you have 9 times the log base 6 of 3. So then you think to yourself, okay, 6 to what power is 3? It's very tempting to say half, but it's not half because half would be square root. So it just stays like that. There's nothing else you can do, and that's your answer. In B, you're doing the cube root of x. So you have the natural log of x to the 1/3. That's the same thing as the cube root. So that 1/3 is a power. It's going to come down in front. So we have 1/3 times the natural log of x. And that's your answer for B. And then for C, it's the same thing. The parentheses don't matter, and the log of two things being added needs to just stay together. So you can bring the 2 down My bad, it was like into 4. Bring the 2 down, and you have the log of x plus 4. And that's your answer to part C. Okay, so like I said, now we're going to take and we're going to put them together. And we're going to still expand our logarithms. We're just going to be using more than one at a time, more than one of these rules. So checkpoint 4 is to expand. Okay, for problem A, you have log base b of x to the 4th times the cube root of y. All right, so I can kind of see we've got a little power rule in there. We also have some product rule in there. No quotient rule for this one, though. So the first thing I'm going to do is split them up. So the two things being multiplied, they each get their own log. So we have log base b of x to the 4th plus log base b of the cube root of y. Now that cube root of y, I should rewrite this, that cube root of y is the same thing as y to the 1/3. Now each of those has a power, so I'm going to just take each of their powers and bring them to the front. So those totally expanded will be 4 times log base b of x plus 1/3 times log base b of y. And that's your answer. That's as expanded as you get. All right. And then there's a problem B for the same checkpoint. I'll take a couple extra steps with it just to show you how it works. All right, for B, you have log base 5 of the square root of x over 25y to the 3rd. Okay, so you actually have three things here inside the log. You have the square root of x, you have the 25, and you have y to the 3rd. I'm going to split the division first. And the division gets split with a minus. So you have log base 5 of the square root of x minus log base 5 of 25y to the 3rd. Now those two are being multiplied, the 25 and the y to the 3rd. So our multiplication is going to become addition, but you have to be careful because the whole thing is being subtracted. So you have minus, and then you really do need a parenthesis. Log base 5 of 25 plus log base 5 of y to the 3rd. So what ends up happening is this minus needs to get distributed to both. And you would have log base 5 of the square root of x minus log base 5 of 25 minus log base 5 of y to the 3rd. Now, if I were to ever do this problem again, I would not go through all that. I'd actually go from here right to here, because anything on the top gets a positive log, anything on the bottom gets a negative log. And if you just think of it that way, it works just as well. Okay, but we have some powers we have to deal with, so we're not done. So log base 5 of x to the 1/2 minus, now this one, I can actually evaluate that. I'll do it on the next step. And this one, log base 5, y to the 3rd, that's fine. I just rewrote this one. Like I said, I'm doing extra steps. It's your notes. Okay, so I'll bring the 1/2 down in front here. 1/2 log base 5 of x minus. Now this you can do, because 5 to the 2nd power is 25. So that's a minus. And then here, bring the 3 down in front. you have log base 5 of y. And that is your answer. All right, so that is completely expanded. All right, now we're going to go the other way. Now we're going to write as a single logarithm, which means you're going to condense it. So starting with checkpoint 5. All right, checkpoint 5 is to write as a single log. Okay, for the first problem, we have the log of 25 plus the log of 4. And the rule still applies that you evaluate anything you can. So this one we have 2 logs with a plus. They both have the same base, which is 10. So we can put them together with multiplication. So it'd be the log of 25 times 4, which is the log of 100. Remember that it's a base 10. So 10 to what power is 100? It's 10 to the 2. So this one we were able to simplify all the way down. So it ended up just being a number. Problem B, we have the log of 7x plus 6 minus the log of x. Okay, so 2 logs with a minus becomes division. So we're going to do the log of the top, 7x plus 6, divided by the bottom, which is x. Show that we're taking the log of the whole thing. Careful with this. Some people put the whole thing over x, and then it's wrong, because actually only the 7x plus 6 is being divided by x. And that's your answer. Okay, these two did not have any power rule in it, but checkpoint 6 will. So I'll put all that together. All right, checkpoint 6 will have the same directions. So checkpoint 6 we'll write as a single log. Problem A, we have 2 times the natural log of x plus 1/3 times the natural log of x plus 5. All right, so we actually want to take care of those powers first. So I'm going to bring the 2 up, and I'm going to bring the 1/3 up. So we have the natural log of x squared plus the natural log of x plus 5 to the 1/3. Okay, so now we have 2 logs with a plus. They're both base e. That's why it's natural log. 2 logs with a plus becomes multiplication. So we'd have the natural log of x squared times x plus 5 to the 1/3. And that's actually okay as an answer, but the 1/3, really it's better if you write it as x squared and then the cube root of x plus 5. And it would be a good idea too to just put parentheses around it to show that you're taking the log of that whole chunk. Just kind of makes your answer crystal clear. All right, and then let's look at problem B, where we have 2 times the log of x minus 3 minus the log of x. So 2 logs with a minus. We have a power here. This number can go up to the power, so we have the log of x minus 3 squared minus the log of x. So 2 logs with a minus, that becomes division. I'm going to put a bracket around it just to show that it's all together. So x minus 3 squared, and it really shows that when I divide by x, it's definitely not under that log. And that's the answer. You're going to have to enter these in my math lab, so you'll just have to be careful how you enter them. When you're doing the homework, you can always do a problem more than once if you discover the way they want it entered needs to be specific to whatever they want. All right, see, we have 1/4 of the log base b of x minus 2 log base b of 5 minus 10 log base b of y. Sorry, that 10 and log kind of blend together. Look like LOLOG or something. All right, so this is kind of a sister problem to the other one because we have 2 minuses. So the positive log goes on the top. These 2 will go on the bottom. But I'm going to deal with the powers first. So this will be log base b of x. And then the 1/4 from the front comes up to a power. Here the 2 from the front comes up to a power. So log base b of 5 squared minus, and then the 10 comes up to a power. Log base b of y to the 10th. We could put them together now, or we could kind of deal with these two. The 4th power is the 4th root. The 1/4 power is the 4th root. So you could write that as the 4th root of x. And then this would be log base 5 of 25. Yes, this whole thing would just be 2, but we're not going to do that because we want to combine it all. And this one just stays. All right, now I'm ready to squish it all together. So we have log base b of the 4th root of x over the 25 and the y to the 10th. It's much neater when it's all written in just one log. Okay, so that's that one. If you have any questions or anything, feel free to ask them, especially through Teams. I keep that open pretty much all day. I help my kids in between, so if I'm not on, it generally means I'm doing 1st grade math instead of college algebra. Okay. The next thing we need to learn is the change of base formula. And the new calculators kind of make this unnecessary. Even some of the scientifics don't need the change of base formula anymore. So it's going to kind of be up to you and whatever calculator you're using. I am going to post something. Hopefully by the time this video is posted, I'll post a way you can get a graphing calculator on your computer if you want. Or just use a scientific. It's up to you, however you want to do it. But the change of base formula is log base b of m. If that base b isn't what you want it to be, you can give it any base by doing log base a. I say of the big, but I mean the bigger font. It could be a smaller number. So log base a of m over, it has to be the same base, but log base a of b. You just split these two up. Okay, and the most common way to do this is with either common logs, so the log of m over the log of b, or as a natural log of m over natural log of b. And what this basically helps you do is put things in your calculator that you wouldn't have been able to put in otherwise. Okay, so I'm going to do actually checkpoint 7 and checkpoint 8 at the same time. And that's to use change of base. Both of them are. And both of them are actually the same problem. We're going to evaluate log base 7 of 2506. Okay, so 7, checkpoint 7, says to use common logs. And then checkpoint 8 says to use natural logs. Alright, so using common logs, that's your base 10. You would just do the log of 2506 over the log of 7. We'll find out what that equals. Using natural logs, you'd have the natural log of 2506 over the natural log of 7. And we'll find out what that is. Okay, so this one you have the log, and it opens a parenthesis for you. That's important. Log of 2506, you have to close that parenthesis. There are scientific calculators that do that too. And then divide by log of 7. You don't have to close that one. So you get 4.02. And if you do the exact same thing with natural logs, natural log 2506, close parenthesis, divide by natural log of 7. The two logs do have to match though. You get the same answer. It's just two ways of evaluating the same problem. The other way you could do this, if you're going to use one of these calculators, which that's actually what I'm going to show you how to download on your computer, or there will be a link in Teams that there's some directions that show you how to download it. But if you go to math and arrow down or arrow up to this log base, it says A, so it's after the 10th one. Log base, it sets the log up like you want it to be. So log base 7 of 2506, and you get your answer. So if you have a calculator that does it, more power to you. That'll work. All right, any questions? Just kidding, you're not here. So the next section, 4.4, is actually a really important one. It's solving equations. But you have to have 4.2 and 4.3 down pretty good in order to do it. So I would definitely get that 4.2, 4.3 homework done, just do the practice. And then we'll tackle 4.6, which is the solving equations. So have a good day, stay safe, and I hope to talk to you all soon.